Hello everybody. Welcome to my YouTube channel AI Nexus, where we are going to talk about artificial intelligence in detail. And we're going. This particular series of video lectures has been designed and developed and presented by Dr. T.V. Gita, which is myself, and Dr. M. Saranya. And this explores the exciting world of AI, and it is meant for everyone. It is meant for people who do not know anything. So it starts from basics. It talks to people who want to use AI, to understand AI, and also for people who are formally studying AI and all its subtopics. Okay, so please do subscribe to our channel, which is AI Nexus. I hope you will find it very useful and very exciting. Now, in this particular video lecture, we are going to talk about the working of AI from the machine learning viewpoint, because machine learning is today the crux of most AI applications and where AI is used. So, in this video, we will be talking about machine learning from a broad perspective. Then we will be giving some definitions of machine learning through the era, and then we will be talking about data point and features, very important concepts associated with machine learning. Then we'll see with an example how machine learning learns from experience or data. Then we'll give a machine learning workflow, and then we will talk about the differences between AI, machine learning, and deep learning from whatever has been discussed in this particular video. Then we'll talk about some of the benefits of machine learning, and then we'll talk about why we talk about machine learning now and some of the challenges of machine learning. So let us begin. The first is a broad view of machine learning. So machine learning is one way to achieve AI, or it's a subset of AI. And again, it allows machines to learn from data. That is the fundamental aspect of machine learning, which we'll be talking about again and again. So first question we have to ask is, why is this machine learning hard? That is because it's different from human beings, obviously. So when a human sees an image of an elephant, it understands it's an image. It doesn't have to, human being doesn't have to understand anything else. But what the machine sees is pixels. So it does not understand it as an elephant. Now, so the machine learning is about teaching the computer about the world. So some of the questions that ask is, what does it mean for the machine learning to learn? What does it mean to learn? Then what has to be the output? And how do we represent this world that is seen to the machine? These are three important questions. So if you do this, if you want this to happen, first we have to observe the world, which means data has to be given. And then models have to be developed to match this data or understand this data. And it has to model the difference between two images. Okay, so that means it has to represent the image and also understand how to represent the difference between the two images. And then once the computers learn the understand or develop the models, it has to learn to apply it to new unseen data. So what is this learning we are talking about? First and foremost, unlike AI, there is no encoding of knowledge by humans. That is, humans do not encode knowledge. So what do humans give? It gives past observation. So machines learn automatically from past observations and then apply it to a given situation. Now, there are two aspects to this. Does it model well? That means, can it model or accurately predict already seen data? That means, does it model the already seen data well? But that is not learning, isn't it? So then, does it generalize well? When you give it a new unseen data, can it predict well? That is the generalization aspect in very simple terms. And machine learning is based on mathematics, such as statistics, probability theory, information theory, and optimization theory. This is the basis of machine learning. Now, let us look at some of the definitions of machine learning through the ages. It changes as we go along. The first definition came by Arthur Samuel. He's in 1959. He's called the father of machine learning, actually. And classic definition, he says that it gives the computers the ability to learn machine learning without being explicitly programmed. Till now, there was only traditional programming. So, without explicitly being programmed, it can learn. That was his definition. Then came the definition by Mitchell, Tom Mitchell in 1997. He's written a book also on machine learning. He says a computer program, machine learning, is a computer program that learns from experience. Okay. E, let's assume the experience is E, and that experience or data is given with respect to some task T, and you also have a performance measure defined P. And if its performance on that particular task, as measured by the performance parameter P, improves as you give more experience, then you call it machine learning. That was his definition. Then came the definition by Abu Mustafa in 2010, where he said very simply that machine learning is the process of turning data into information and information into insights. This is a very general definition. Then came the definition in 2018 by Google AI, where he said that machine learning is a method of data analysis and which automates analytical model building. So here he talks a little bit about model. Then McKinsey in 2024, he defines machine learning as a form of AI that can adapt to a wide range of inputs, including large data sets, and also work with human instructions so that it can detect patterns and make predictions and recommendations. Then came finally by 2025 in a Coursera article, they say machine learning is again a subset of AI that allows that can create self-learning models that can predict outcomes and do classification. So these were the definitions. So let's look at the crux of the definition: not explicitly programmed, automatically improve through experience with respect to a task, turning data into information and information into insight, data analysis or automatic model building. So model comes into the picture. Detect patterns. Now we are talking about patterns to make predictions, and it is trained on data sets so that you can create self-learning models for doing predictions and classification. So this is what is the crux of the definitions of machine learning. So let us talk about data points and features, very important concepts associated with machine learning. So let us take an example of a weather parameters and used for rain prediction. And this is a data set table. So here we have one data point, which is the weather conditions at one time point, and the features are the measurable properties associated with weather. Now let's take one row. This corresponds to one data point, that is one observed sample, and all the feature values associated with it. Here you have 30, 70 and 10 as the feature values associated with that data point. Now, why data points matter? The more the data points you have, this is a toy example, so don't think of this as an actual table. The more data points, it has to be in thousands and more than thousands. And more it is, the better is the learning process. So each data point will help the machine learning model to understand the patterns better. Next, we talk about features. So the column represents feature. It is one piece of information about a data point. For example, DP1, that particular 30 is about one data point. And that whole column talks about temperature for all the data points. So it is actually describing what we measure. Here we are measuring temperature, humidity and wind speed as the features. And then now type of features can be different. For example, numerical, age, temperature. It can be categorical like city, Delhi, Kochi, Chennai. Binary, pass, fail. Text. Here it's a little different. Reviews, articles, anything it can be, but it has to be represented differently, which we will talk later on. image, it can be pixel values, it can be shapes, it can be edges, and a time-based feature also. It can be the hour at which something happens, or the date, or the month, and so on. Then you have the output that you're expecting. So here, whether it will rain or not. So it's a binary output, and there will be one point where you don't have the value. So you have to use the pattern to learn the output. Now, when you look at machine learning task mapping, the features are temperature, humidity, and wind speed, and the label here is rain. Here we are given as S or no. Now, if you look at it from a mathematical point, the data point is written as a vector. For example, x, x1, x2, xn. It can have n number of features, and where each xi is a feature. And then you have, so x1 is this, so dp1, dp2, dp3 we have given. So each x or dp1 is a data point, and each number inside that is a feature. So this is about data points and features. Okay. Now let's talk about one machine learning example where instead of looking into rules, machine learning does not look into rules. It looks at examples data and finds pattern and uses those patterns to make new predictions. So let's take a traffic light detection. The goal here is learning to identify which traffic light color is shown in a new image. Now, the input or the data points can be number of traffic lights images along with the label. Label here is whether it's red, yellow, or green. And when you talk one data point, it is one traffic light image. You should give lot of images like that. Then you have to convert that image into pixels because the machine does not understand the image. So you convert it into pixels. These are the feature. So the pixel color value here in this example, color is important. So pixel color value is the feature, and it is actually represented as a vector. All the pixel values put together, okay, for a particular image is a vector. So here it's shown as 10, 40, 15, and so on. And then you have the actual machine. This is given as input to the machine learning model. So what does the machine learning model learn? It learns more red pixels are there, then it's a red light. More yellow pixels are there, it's a yellow light. More green pixels is green. No manual rules are given. So it learns automatically. And finally, using this model, when it's given a new image, it will predict. So for example, here it predicts that it is green. And so the label that it is given as output is whether it's red, yellow, or green. This is a simple way of understanding how it learns from experience. Now let's look at a machine learning workflow. So first you have to give the problem specification, what is the scope, and you must be sure that it is a feasible problem statement because you must be able to collect data. If you cannot do machine learning. So next comes the collection of relevant data. This is very important. Depending upon your problem specification, the relevant data is important. It could be many types like photos, text, sales numbers. It could be depending upon your problem. Then comes pre-processing. All data that you get may not be very good. So you have to clean it, you have to normalize it, like average it out, remove missing values and so on. So this is also important. After that, the most important part is you have to decide on what are the features that you need or useful input variables that you need for that particular problem. It can change depending upon the problem. So feature engineering and selection, this has to be done by the humans. Then the next is actually the learning algorithm. This is where it learns a pattern. So the model is created, and later on it can also be tuned and it can adjust to its mistakes. So train model and tune parameters. Then comes the test and evaluation. So you have to test on unseen data. Then only learning happens. If you just test on already seen data, then nothing new is happening. So you have to test on unseen data. And finally, you have the deploy and improve. So you model if it makes predictions of real world tasks. as you give it more data, it improves over time. So this is the 7 steps of a workflow model. Now, what is this magic of ML that people are talking about? There are no hard-coded rules. So the human expert doesn't have to think about rules. What he has to do, or the human have to do, is give examples so that the machine can learn from it. Another important aspect is as you give it more and more data, it improves with experience. And it is able to work on unseen data. If it is not able to, it is not learning. So this is the magic of machine learning. Now let us look at some examples to understand the machine learning workflow. So first you have to set the goal. Okay, the example we have taken is energy consumption prediction. The important point that first you have to do is you have to choose the features. For example, past energy, weather and time could be the features. And then you have to collect the data. You have to collect all this data, normalize, clean it and do everything. Then you have to train the model. What do you train it for? Learn the patterns of usage. And then you have to test and evaluate the model. So you have to compare what is predicted to already existing real value data. Then you have to actually predict for an unseen data, like for example, tomorrow's consumption. And then you have to improve the hypothesis, for example, by adding a feature. So here you could add season as an additional feature. Now let's take another example, disease progression prediction. So here again you have to choose the features. So patient tests and his history could be good features, and you could collect the treatment history, and you can train the model. You have to learn the progression patterns or trends here. Again, you have to evaluate the model by validation with existing patient data, and then you have to predict the progression, future health condition, what it will be, and then you have to, if necessary, you have to add an alternative feature. Here you could have more clinical data than what you used in the beginning. Okay. Now let us look at AI. Now again, we are looking at these differences from what we have discussed in this slide. So for example, machines act smart like humans. It's an umbrella term. So it is an intelligent machine is what we call it. For example, a chess program, voice assistant, and so on. Machine learning learn from data. It's a subset of AI. So instead of writing rules, which we have discussed, it gives data, learns patterns and improves with experience. So YouTube recommending videos based on what you watch. The more you watch, the better will be your recommendation. And then comes deep learning. Here it needs large data and more computing power. This is a subset of machine learning. And it uses neural networks with many layers. Important part is it learns the features automatically. In machine learning, humans were giving the features. Here the features are learned automatically and it is able to understand complex patterns. So it's very good at images, speech, language processing. So face recognition, speech to text, self-driving cars. Here in these applications, deep learning is used. Now let's look at some of the benefits of machine learning. One, it automates complex tasks like diagnosing diseases. You can put in a large number of parameters to do that. Then learns and improves over time. Your YouTube recommendations, as I already told you, it improves as you watch more videos. Then handles large amount of data. Social media data analysis is an example of this. Improves decision making, like it can forecast demand of products or whatever, and so it can improve the decision making and reduces human error. For example, in a banking system, it's automated, it can reduce human error. Then it can enable personalization. It can give product recommendation to suit you by gathering data about you. Then saves time and cost, predicts traffic and gives the shortest route. It's an example of that. Enhances security, it detects fraud. One of the main applications of ML in banking and any financial transactions. Helps discover hidden patterns. For example, it can detect early stage diseases from medical scans which may be missed by doctors. No, may not be experienced doctors, but still. And finally, enables new innovations. For example, self-driving cars and voice assistants, they were not in the picture before machine learning came into being. Okay, now let us talk of why at this current state of affairs we have ML gaining so much of importance. The reasons for that are manifold, like explosion of data. There is lot of digitization. There is huge amounts of data available. There's powerful hardware like GPU and TPU to handle this data centers, as you have heard of AI data centers, as well as to analyze this data. Then there are better algorithms to handle this data like deep learning, transformers, large language models, and all these together give better accuracy. Then there are cloud computing platforms available like AWS, Google Cloud, Azure, OpenAI, and so on, so that this makes machine learning democratized. Okay, that means it becomes easier for people to, not easier, it becomes possible to use this AI. And then practical application with real business value, economic value. So in every industry, AI has become an important factor. Then there is an open source revolution, including availability of TensorFlow, PyTorch, Scikit-learn, Hugging Face, so that now ML becomes easy to use, like easy to learn, experiment, and deploy. So all these factors together make ML useful, affordable, and powerful. But at the same time, there are some challenges. What are these challenges? This availability of data itself makes it possible that you're not expecting more. So you need huge amounts of data to give good solutions. But at the same time, some of this data is of poor quality and is also noisy. And there are data privacy and security issues because systems may take data from you without knowing it, so, and using it in a way that you don't know about it. This is to talk about even everyday applications. And there is a lack of explainability. It's called the black box problem. It is difficult to interpret the decisions made by AI systems. And of course, because of the availability of GPUs and TPUs, there is higher computational cost. And there's a continuous monitoring required. And it's not that the systems built today can exist independently of what was there before. So there's a need to integrate with existing systems. And finally, there are ethical and social issues associated. Ethical could be if a loan is denied to you, you do not know why it is denied. You need to know that. So that is explainability. And social issues like, are everyone included in this AI world? That is another question. So today, machine learning is powerful but fragile. It is really, really data hungry, and it is hard to explain. The conclusion is we have given a broad view and briefly described the steps in understanding machine learning. Then we gave the workflow, and then we discussed benefits and why machine learning now and some of the challenges. And then we have looked at the machine learning for some references have been given. So thank you, and there are more videos available. So please subscribe to our channel AI Nexus, and this is the link for you to subscribe. And I do need feedback from you regarding what you would like to listen to, and we will develop and give, or something relating to these videos also you can give feedback. So thank you once again.